2, 1. Hello, everyone. Welcome to World Oceans Day. Woo-hoo! A wonderful day to celebrate everything having to do with water and our ocean and the amazingness that is around us. Our oceans cover 70% of the planet. 70%. So it's so important that we're talking about today on how to be mindful of our ocean environments and mindful of the animals that live within the ocean. Now, for our friends who are joining us right now on YouTube, because I know there's a few classes who are, I'm going to remember here in a second whose class for sure is there. I know that my friends at Muriel Martin are joining, but also we have a class from Kelowna, Miss Evansdale's class. Miss Wonder's class from Calgary, not from Calgary, it's from Kelowna. I will change that in a minute. But we have so many friends who are joining us on YouTube and joining us here in the room. And our question for today, as we head into our ocean event, is which ocean animal can have the most babies at one time? And so we kind of, it's a two-parter in it, which animal, but also how many babies? And so we're here in the Zoom room with our friends from around Canada and our guest speaker from OceanWise, Andrew, and our guest speaker, Nyla, from California, who's joining us too. We have seals, we have planktons, we have sunfish and seaborn horses, we have octopuses and crabs and whales and, oh my goodness, ocean spiders. I don't even know what an ocean spider is. There's so many animals that are being guessed. Nyla, do you have a guess on which ocean animal might have the most babies?
I'm placing my bet on the seals.
Seahorse, okay. How do any of our friends here in the room? How about Miss Brandt's class? Do you guys have a guess for us? You guys can just shout it out if you're Miss Brandt unused for a second. Just yell out a couple of answers. Octopuses! Oh, there's so many great guesses coming through. Jessica, do you see anything coming in on YouTube? People guessing? I bet there's a lot of there's seals here. Some a lot of more sea butterflies. Butterflies are not an ocean animal, but they might fly near the ocean. Nice try. Oh, Ross on YouTube says seahorses. Okay, Andrew, I'm gonna need the answer. I'm gonna drum roll.
Everyone, this is a hard question, and in a way, it's a little bit of a trick question. So I've seen a bunch of people say seahorses already, and seahorses is the first answer that comes to mind for sure. Seahorses can have up to 2,000, potentially more than 2,000 kids in one go, and that means they give birth to all of those babies. They hatch and they give birth pretty much at the same time. And it's pretty interesting because the female will actually pass the eggs over to the male to hold onto in a little pouch. And so the male is the one that effectively gives birth to all of these babies. But my friends, so seahorses is kind of the first answer. But there are other animals in the ocean that are broadcast spawners, and some of them we're talking about today, which means they release their eggs into the ocean en masse. And see, like animals like coral and sea stars can actually release up to 65 million eggs at a time. And so if those eggs are successful, then maybe sea stars actually have some of those babies in the ocean. But awesome. These were some fantastic guesses. And I'm excited to kind of talk about ocean babies today and some of the amazing ways that ocean animals reproduce and the life cycles that they have. So we're going to be talking about some of the really cute ones. And then we're also going to be talking about some of the really interesting and a little bit more obscure animals and then their babies in the ocean. My friends, just to start, I have a quick question as well. Does anyone know what plankton is? I saw a couple answers in the chat talking about plankton having those babies. But can anyone tell me what is plankton?
Oh, there's some people who don't know, but Arushi and at Mill Pond School has raised her hand.
Yeah, go for it.
I'm pretty sure it's like these really microscopic animals that I'm not really sure, but like I think they might, instead of animals, I think they're plants. Honestly, I'm not sure.
That's a really, really great start to that answer. So it's a bunch of very small, microscopic, really tiny animals and plants as well, and other like algae and other organisms. Does anyone have anything else to add to that?
Oh, they feed on, Miss Holden's class said they feed on bacteria?
Ooh, awesome.
And
There's
whales?
definitely- Whales eat them? Absolutely. Plankton is really important to a lot of really large animals like whales. Do you have one more thing to guess about what plankton is?
Let's see. Oh, everyone's just waiting for the answer from you, my friend.
Ooh, plankton helps give us air. Absolutely. So plankton, it's really complicated. Plankton's super cool. It's a mixture of things we call phytoplankton, which are like plants and algae, and those use sun to make for energy. And those are the ones that help us with oxygen and help give us oxygen. But plankton is also made up of zooplankton or zooplankton, and those are little tiny organisms. A lot of those are actually ocean babies. So a lot of what plankton is just a bunch of little babies in the ocean that are swimming around like baby sea stars, baby sea urchins. And today we're going to be talking about them. So I'm going to share my screen with everyone right now. And we're going to dive in to learning about some of the babies in the ocean. So first of all, we can't talk about ocean babies without talking about the absolute cutest of them. This is a baby sea otter. And baby sea otters, they have a very intimate relationship with their mothers. And their mothers actually use kelp. So that's seaweed. They tie their babies up with kelp so they don't float away, because the mother has to go and hunt and find some food. And so she'll tie her baby up in some kelp so that baby does not float away. We also have here a baby sea lion, which is super, super cute. Absolutely adorable when they have like big flippers that are almost too big for them, kind of like how puppies do. We have a baby seal, which are also insanely cute. Sometimes you can see baby seals off of the coast of British Columbia as well, which is pretty amazing. And then finally, someone else mentioned earlier in the chat, sea turtles. And this is a baby sea turtle. Sea turtle babies, they are very cute. A mother sea turtle lays many, many eggs, and those turtles have to undergo a migration as soon as they're born. So they're born on land, and they have to run as quick as they can using their little flippers to get to the ocean to try to find some food and to survive. But my friends, today, we're going to dive in to some of the animals that we don't see as much when they're babies. And we're going to talk about some of the life cycle and some of the ways that animals reproduce. So I would like you to quickly think, whose baby picture is whose? We have 3 baby pictures at the top here, and we have 3 adults at the bottom. And I would like you to guess. You're welcome to put it in the chat. I'm not going to give you the answer quite yet. I'll give it to you later. But I would like you to think maybe, whose picture is whose? So I'll give you a couple seconds to look through this and make some guesses.
That's a hard one. They don't really automatically align. I'm excited to hear the answer.
It's kind of interesting because there's some misleading parts of this, but I promise you, this is not a trick question. These are actually, you can match these, and one of them will be the baby for the adult.
Wonderful. And for those who are on YouTube, you put your answers in there too, because we have someone who's on YouTube listening to what you're saying and bringing it back in here.
All right, I'll give you a couple more seconds to give this a look over, and then we'll dive in and learn about some. And maybe you'll, throughout when we're talking, you might get a better idea of who is who. Awesome. So, for a life cycle, a lot of the animals that live in the ocean, such as fish and invertebrates, so animals without a backbone, they undergo a life cycle that starts off as an egg. So when you're young and you're a fish, or you're an invertebrate, you often start as an egg, kind of like a chicken egg. And then when you hatch, you become some sort of larvae, so some sort of small animal that is very tiny and is swimming around in the ocean and trying to eat enough to get big and grow. And usually it's a bit of a lonely life once you are a larvae, because your parents, they don't have enough time to invest in your development. But as a larva, you can swim around and you do your best to survive until you turn into an adult where you can produce more eggs. And my friends, in the ocean, there's some really beautiful parenting methods. So here we have a couple of wolf eels, and it's really cute because they protect their eggs. They're very devoted parents. So as you can see here, there's a male and a female wolf eel. And the female, actually, as soon as she lays all of her eggs, which is this clump in the middle, she wraps herself around those eggs and protects them from the outside. And then the male actually comes and wraps himself around her as well to protect her and the eggs. And so they'll only go off and feed one at a time. So they'll go find some food one at a time to make sure those eggs are never left unguarded. And so this is a really nice little parenting style. The eggs get a lot of attention. And when they hatch, hopefully they'll have a chance to go eat and survive and live really well. And my friends, not everyone gets that kind of treatment in the ocean, but there's some really other interesting ways and other animals that like to swim around when they're young, when they're larvae. So this, my friends, is a sailfin sculpin. And this is one of a really, really cute small animal that you can actually find in the wet lab exhibit in the Vancouver Aquarium and in some of the tide pools in British Columbia. So we'll watch this quick video of this sailfin sculpin baby swimming around. So this sculpin is floating around. It's trying to find some food. Does anyone have a guess of what it might be looking to eat? Any guesses of what it might want to eat? Jordan, do you have a guess?
Seaweed.
Ooh, seaweed. Yeah, that's a really, really good guess. So it might be looking around for something like a vegetable, a sea vegetable, or algae.
Miss Bychuk's class says that they're looking for bugs, and Johnny says plankton, and Arushi also says plankton. Some algae are guessed. Well, there's a lot of, oh, Nicole wonders if it's a herbivore.
Ooh, yeah, so absolutely. Those are all really fantastic guesses. Usually that little sailfin sculpin is floating around and eating phytoplankton. So it's eating the plankton that's made up of algae. So everyone was almost right. They are, in this case, kind of herbivores. They will eat a lot of the little algae and seaweed that's floating around in the water until they get super big and they turn into an adult. So I would like you to spot in the next picture. I want you to see if you can spot the adult sailfin sculpin. So we have the little baby picture on the side there. Can you spot the adult?
It's really camouflaged.
Yeah. So the sailfin sculpins are pretty cool because they're really good at camouflage. Sarah's absolutely right. They camouflage against the rocks at the bottom of the ocean. Does anyone have a guess on where that sculpin is?
People are stumped. There's nothing in the chat.
Oh, all right, my friends.
They're stumped.
Are you ready?
Mhm.
It's right there.
Right
So
in the
this is
middle.
right in the middle of the picture. Right staring. It's not actually staring right in the face. It's got its tail pointed towards you, which is a little rude, but that's okay. So this is actually a very pregnant mother sailfin sculpin right in the middle there. But she's really good at camouflaging. So you can see how you can identify a sailfin is they have these really, really big and impressive fins, which was what gives them their name. And as a baby, you can actually see that sailfin developing so they can move around through the water super well and super efficiently. And so this sailfin sculpin is pregnant with her eggs. So soon she'll lay her eggs. And if they get fertilized, then they'll turn into other little baby sailfin sculpins like this. And they'll go through this other process. All right, my friends, this is another animal. This is one we kind of talked about at the beginning. It is a sea star, specifically a sunflower star. And it's in the process of doing something pretty cool. Does anyone know what's going on? What are these little red dots that are being spawned in the water? Any guesses?
Maybe like it's pollinating.
Ooh, we've got pollination as a guess. We've got a couple in the chat that's saying eggs.
Yeah, lots of eggs guesses.
Awesome. Absolutely. So that these are eggs. So all of these little flecks of red in the water are eggs that sunflower star is releasing into the water. And this is something that we call broadcast spawning. So if you think of broadcast spawning, it's pretty cool. It's a really, really efficient way to reproduce because what you do is you just release your eggs into the ocean and the other male sunflower stars or sea stars, they release their sperm into the ocean. And those two reproductive components, they mix in the ocean and they make as many babies as they possibly can. So as I said before, sea stars can actually, they can broadcast about 65 million eggs over the course of a couple hours. That's a lot of eggs.
Wow, and how many do you think are fertilized in the end of all of that?
That's a really good question. I think it's a little bit harder for us to tell because it depends on the ocean. It depends on how many other male sun star or sea stars are there, but I would say probably about 50% of them get fertilized, which is still like 32.5 million eggs. And then
That's a lot of babies.
That's a lot of babies. That's a lot of babies. And you might ask, why isn't the world not completely covered in sea stars and sunflower stars? And that's because a lot of those larvae are really good food for things like whales. Because these broadcast spawning babies, they're really important for the rest of the ocean. They provide food. And it sounds a little bit wild and a little bit kind of scary, but this plankton, these tiny little larvae are really amazing for the rest of the ocean. They provide life for all of the other animals that live in the ocean, from things like as small as little fish, like herring, to things as big as great blue whales and other massive, massive mammals. All right, my friends, so we've talked about a couple different animals. I think we have next. Oh, this is the next part of the life cycle of the sea star. So this is a sea star larvae. So this is once the egg has hatched and become fertilized. It looks like this. And this little thing is swimming around. It's kind of shapeless. It's got a couple kind of antenna, but they're more of like, they're used for mobility. So they help that larvae swim around in the ocean. And eventually, once it eats enough food and develops enough, it will turn into this little guy. And this starts to look like a baby sea star. And so it's starting to develop its tube feet, which are really important because that's what it uses to stick onto rocks and help it to move around. And once it gets big enough, it actually looks like this. This is a baby sea star in the Vancouver Aquarium. And as you can see, this is sped up a little bit, but it's using those tube feet to walk around and try to find food because sea stars are actually one of the wildest and scariest predators on the ocean floor. As you can see, they can move relatively quickly and their mouth is at the bottom. So their mouth underneath is used to eat many, many different things at the bottom of the ocean, which is awesome.
Amazing. There's a lot of wow coming in on our chat here. That's pretty awesome stuff.
Yeah, yeah. Have you ever touched a sea star? Yes, I have actually. So in BC, there are sea stars that you can find on the coast and in tide pools. And if you touch them really delicately with your pinky finger, and you can just like brush them, sometimes you can pick them up if they are outside of the water and just look at them and place them right back down where you found them. But sea stars are pretty cool, and there's a lot of them because, as I said, they make many, many babies. And the difference, I'll answer one more question. What is the difference between a starfish and a sea star? Well, sea stars are the more correct name for starfish because starfish are not actually fish. That's the secret of today. Starfish is a really badly named term because starfish are not related to fish. They don't have gills, so they don't have to swim, and they don't have fins. They don't have many of the things that we make a fish a fish. But yeah, great question. Fantastic. Awesome, my friends. We're going to talk about a couple more ocean babies, and then we'll do a bit of a quiz. So the next one that I want to talk about is one of the coolest types of animals. They are called cnidarians. Does anyone know what kind of animals? Has anyone heard the term cnidarian before? It's a bit of a big word. You can do thumbs up if you've heard of it, thumbs down if you haven't in your window. All right. I'll share with you what a cnidarian is. Who's this? Sorry, what was that, sir?
Lots of thumbs down. They're curious about what this is.
Yeah, it's a big word. It starts with a C too. Anyway, so cnidarians are actually a big group of animals, but they contain animals like sea anemones. Has anyone seen a sea anemone before? Thumbs up if you've ever seen a sea anemone. Ooh. Has anyone seen a jellyfish before? In my background? Yeah, so jellyfish are also members of the Cnidaria family. And the last one that is a member of the Cnidaria family is actually coral, because coral is an animal and it is related to sea anemones, which is super, super cool. I think it's pretty wild. This is one of the craziest types of animals. But when they reproduce, they can actually clone themselves. So what they do, some of them, often they'll mix their sperm and their eggs to make larvae, just like the other animals we talked about. But then those larvae can clone themselves. So they can make replicas of themselves and reproduce what we call asexually, which means you reproduce without needing another animal. You can just clone yourself and make more of yourself. So we'll watch a quick video of it's actually a jellyfish that is cloning itself, which is pretty cool. So everyone can see this. Oh, let's make sure that you can hear this as well.
Hi, my name is Mackenzie Neal, and I'm the Assistant Curator of Propagation, but I'm also known as the Jellyfish Queen. Strobilation is the process by which polyps start dividing and they produce a phyra, or baby jellyfish. You can see that there's a bunch of them that have started strobilation. You can see the separation on some of the polyps where the discs are forming. There's two really nice clumps of a phyra. One of those clumps just fell off. Usually they pop off as individual phyra, but sometimes, like you just saw, they come off as clumps. And those phyra will continue to break away and start swimming away and grow into adults.
So I think that's pretty cool. Basically what's happening there is these polyps, these little tiny baby jellyfish, are cloning themselves, and their clones are breaking off and then floating through the water and turning into full adults. Maxwell, did you have a question at all?
So when I saw when I saw like a different jellyfish, it had like round corners.
Oh, when you saw a different, like the jellyfish has these kind of like interesting little circles on it, like these kind of cool rounded corners. That's a really good observation. And that might help us with the baby matching activity that we saw before. Remember that little slide that was like, who is who? Maybe think about that, because that's Maxwell's a fantastic observation. And we'll get there in just 1 second. I'll show you quickly here. This is a picture of anemones. So these are anemones that have all come from the same adult. So this anemone, all of these tiny little animals here on this rock are actually clones of one big animal, which I think is super cool. So these animals, these things like jellyfish and anemones and coral, they clone themselves and they populate a large area with their clones, which is pretty cool. So can you imagine if you cloned yourself maybe 1,000 times and there was just 1,000 of you all hanging out together and helping each other survive? That'd be kind of cool. I don't know if you get sick of yourself. I might get sick of myself, but I think that's a really cool concept.
There'd be a lot of food you need in the fridge.
There'd be a lot of food. Yeah, especially if it was when I was a growing kid. When I was 17, I was eating a lot of food. And if I had to feed 1,000 of myself, I would probably be very, very poor.
You have to have a lot of room, because I think there was a question that came through that was like, well, how does the ocean hold all of this? Because it's just like so many animals.
That's a really good question. And how does the ocean hold all of these animals that can reproduce so well? Is basically they can grow these coral reefs. That is many, many animals that are expanding and expanding. And eventually they hit boundaries where there's not enough food in the ocean, so they can't reproduce more. So it's kind of like the idea that there's only so much food to go around. And so eventually you can't reproduce too much, because then there's no food for you and you won't survive. All right, we're going to jump into this matching activity. So your job now is to take of what we've learned and what we've talked about, and maybe some of the things, those observations that you made, like Maxwell made, and try to figure out who is who in this slide again. So do we have any guesses? Would anyone like to be brave enough to guess?
We have 8 matches with 3 coming from our friends at Mill Pond. So
awesome.
A3 is one of our guesses. And I'm going to scroll up to the questions because there's lots of, but someone says 3 and C.
Also a good guess.
Contention.
Does anyone know what 2 is? Maxwell, do you have a good idea of what 2 is?
A little bit bigger jellyfish.
So 2 might be the jellyfish, right?
Yeah, because
Yeah.
I was talking about like torners.
Like these things, right?
Yeah.
Yeah, so 2 is actually B. 2 is the jellyfish. That's when we saw the Ephyra and the polyps when they were cloning themselves. They looked like this. They had all these little corners. So 2 is B. And I think someone's class found that 3, if you remember, that's what a baby sea star looks like. It looks completely different from a sea star. It looks super different. And so A is 3, and that leaves our sailfin sculpin, number 1, with our beautiful sailfin sculpin here, which is C. And as you can see, they have this amazing sail and this is not the best picture. It's a bit of we had to make it a little tricky, you know? Awesome. Do we have any questions, Sarah?
Well, we have definitely lots of guesses. And Mrs. Bycheck's class, someone thought maybe you were trying to trick them, and none of them matched up. That is an ultimate trick.
That would have been an ultimate trick. That's a little bit cruel, but hey, I wouldn't put it past myself. So that's a very fair guess.
Now I see that, Dom had their hand raised, but have lowered it. Now, if anyone has a question, you're welcome to type it here in the chat in the Zoom room. You're welcome to type it if you're on YouTube and joining us. You're welcome to type it there, and Jessica will bring it in for Andrew to answer. Or if you'd like to just raise your hand with the reactions, and we'll also have a chance to go to some of our schools. So if you're in Miss Bycheck's class or any of our classes that are here, you can have your teacher type in the chat, say, we have questions, and we'll make sure that we get to you. Now, we have Tarek and Malik who are starting off with why do octopuses not have bones? They've asked it a few times, and so it's very important to them that we answer this question.
All right, it is a very important question. And this is some questions need to be answered. Why do octopuses not have bones? Well, octopuses are actually, they are related to invertebrates. So they evolved from things that didn't have bones. So that's kind of a why they don't have bones to begin with. It's because they came from things that don't have bones. But my friends, they also can squeeze themselves through really, really small spaces. They use that ability to move themselves and squeeze through really small spaces to help them hide from predators. It can help them to recover when they get attacked by a predator, to regrow an arm. And it can also help them to hunt and to camouflage. They're one of the best camouflagers in the ocean. So having no bones is a really big advantage to these octopuses because they can go about their life and hide in little things, in rocks and caves. I think it's really cool. Awesome question.
Amazing. Now, Miss Holden's class says the teacher wrote that many of the students are interested in jellyfish that are immortal. And what does that mean? And how does it work? And what's going on?
That is a fantastic question. So there is one species of jellyfish that we believe to be quote immortal. Because what it can do is it can go from its adult stage, it can then reproduce, and then it will actually go into its larval stage again. So it will skip the part where it has to die and its children pass on, and it will actually transform back into a small larva and then regrow into an adult again.
Cool.
And so what we've seen is this one species of jellyfish, I think in a lab, can actually do that up to 12 times. So it can go from an adult to a baby, to an adult, to a baby, to it, etc. And so it can do that. And theoretically, in the ocean, it could do that many, many times. The one thing is it probably will get eaten at some point, especially if it gets older. So the chances of it being truly immortal are low. But it is one of the only animals that we know of that can revert itself back to a younger stage of itself and then go back to an adult and do that many times. So that's really, really, really great question.
I have a question.
All right, so we're gonna. Yep. Go ahead.
Why are Why are clownfish called clownfish when they don't look like a clown?
That is a really good question.
That's a good question for what?
I think it might be because of their coloring. They kind of look like they're wearing a lot of makeup. They've got these really big stripes and they're orange, but I'm not actually sure. Does anyone, Sarah, do you have any ideas of that?
Yeah, I have an idea.
Well, we are, I think those are the best guesses, and you are in a good place to know the answer. So I want to make sure that we get a chance for our classrooms to ask questions too, because I know they aren't near their computers. So we're going to have Miss Brandt and Miss Mundor and Miss Bycheck. And if anyone other classrooms would like to ask questions, we can. I know Miss Holden and Miss Evansdale is typing some of their questions in for their students, but we would love to have the others have a student come up and ask a question right at the front of the computer. Now, as we wait, maybe we'll go to Miss Bycheck's class first, and then Miss Mundor's, and then Miss Brandt's, in that order. But first, I know that Tasneem, who just took a bite of lunch, but I know that she's been very patiently waiting with her hand up. So I'm gonna go to her if she's not too busy chewing, because isn't that always the way? Doesn't the waiter always come to your parents at a table and ask when they're eating if they need anything? So Tasneem, are you ready? Are you good?
Yeah, I was actually
Okay.
gonna ask you guys about something why they don't have bones. I was just making a silly guess. I was thinking maybe because you know how they move their hands, make them go like this and even over here. I was thinking maybe because they had to do that for a certain reason and they needed to have no bones so that they could do that.
I think I know the answer why the clownfishes are called clownfishes.
I heard the first. I'm gonna respond to the first one first. So
Yeah.
I think, yeah, the fact that they need to move their arms in certain ways, and the whole way that they like to hunt and the way that they like to hide, it really helps them to not have any bones, and that's a really, really awesome observation as well.
I have another question.
Well, we're going to go to some kids who haven't gotten a chance to ask yet. So first we're going to go to Miss Mundor's class, because I said Miss Bycheck's, but I don't know if anyone's up near the camera because I can't see you. So we're going to go to Miss Mundor's class first. And then Miss Bycheck, if you have someone, just give a little wave and we'll make sure to give you a chance. Oh, I see you now. So you're next. Miss Mundor's class, over to you.
Do some turtles bite?
Do some turtles bite? Yeah, so some turtles, they're a little bit, they're really good at, there's one turtle that lives in the bottom in like sediment in the water. I think it's actually a freshwater turtle. And it's called the snapping turtle. And they will definitely, if you get a little too close, they might think you're food and think your finger is like a fish or something and go for it. Some turtles are a little bit nicer too. Sea turtles, usually pretty chill. Depends on the turtle.
Can you find a lot of freshwater turtles in Canada? Do you know?
Oh, so yeah, there's quite a few freshwater turtles. I don't know if we have snapping turtles. That's a really good question. Freshwater is not quite my domain, but there are quite a few freshwater turtles that we can find in Canada, which is pretty cool.
Amazing. Thank you. Okay, Miss Bycheck's class, over to you.
Where is the poison sac in a jellyfish?
Oh, that's a really good question too. So it's actually pretty cool. On their arms, so if you think about what we usually call tentacles, but are kind of like more like arms, they have little tiny cells all throughout their arms that are full of venom. And so what that does, it's a pretty cool function. Basically, if you touch their arms, it releases a little trapdoor, and from the trapdoor, there's a harpoon with some venom on it that is spring loaded and like spews out of their arms and injects venom into whatever has touched it. It's really cool. If you want to look up a video, I don't have a video of it, but there's a really good diagram. It's one of the most amazing structures you can find in an animal. It's really, really basic and really old, but they don't have a sac necessarily. The venom is distributed through all of their different arms. Good question.
Amazing. That sounds so cool. All right, Miss Brand's class, you guys are next. And then we have, sorry, Miss Coons. I keep saying Evansdale, but that's where they're joining from. So Miss Coons' class has some questions too. We have lots of hands raised. Oh my goodness, everyone has questions for you, Andrew. But we're gonna go to Mrs. Brand's class first.
There we go. Okay.
How can humans help if animals' reproduction is
Interrupted, remember?
interrupted?
Mm-hmm.
That's a really, really good question. So how can humans help if we're interrupting animal reproduction? And that actually brings me to what I was going to talk about a little bit. And I was going to say that plankton and all of those animal babies and all of these ways that these animals reproduce are really vulnerable, which means that they're really delicate. So if you think about ocean temperature and the amount of garbage and pollution that's in the ocean, so plastic and other pollution like oil, that can really affect the reproduction of a lot of animals. So we think that if we think about eggs and fish eggs, if there's a bit of oil in the water, those fish eggs might not survive. They might not turn into fish larvae and fish babies. And so one of the things that we can do is really stop ocean pollution, because that really harms a lot of the animals and the eggs and the reproduction in the ocean. I think that's a really good idea. So if we can put less plastic in the ocean and we can put less chemicals in the ocean, those are two really big things we can do to help those animals to continue to be able to reproduce.
Amazing. Okay, we have so many questions here. And then I know, actually, I think Miss Kuhn's class had a question that related to what you were just talking about, and that they wondered how whales can even see the plankton, because they're so big and plankton is so small. Like, how do they even know there's plankton around to eat?
That's a really good question. I think in a way they don't know, they can't really see it. I'm sure it looks a little hazy in the water, but whales usually open their mouth and just go. They swim and they can probably sense the plankton. I'm sure it smells a little interesting, and I'm sure it looks like something to whales. But usually they'll open their mouth and they get a lot of water. They might get a couple other things, but usually there's a lot of plankton floating around, especially at certain times of the day when plankton comes to the surface to feed. And so it's pretty cool. That's a really good question. And I think that they can sense it in a couple different ways. But a lot of the time they just open their mouth and eat.
All right, Emma has a question. She's been very patient. She's been holding that hand up in the air because it's getting tired. So Emma, ask away.
How do starfish take care of all their babies?
That's a really good question. And the answer is that they don't really. So what they do is they release all their eggs into the water, and the eggs get fertilized in the water. And then they just float around and they eat food and they try to survive. And so it's kind of a style of parenting where you put in the work before and then you let your children free to do their thing.
I guess they don't need a lot of raising then. They probably don't have very good manners.
No, not the best table manners or very good posture, I don't think.
All right, Jordan, I know you've been trying to mute and unmute. We've been having a little competition. So Jordan, over to you. Now's your chance. Ask your question. Oh, there you go.
How many eggs can a dolphin lay?
Ooh, that's a really good question too. So dolphins, they're actually mammals like us. And do we lay eggs outside of our bodies? No, right? We carry our babies inside. So dolphins are mammals like us. And so they can have one, two, I actually don't know if they can have many kids at once. Like maybe they have six tuplets sometimes, or maybe they have twins a lot. But they can carry, I think a lot of marine mammals usually just carry one baby. So a lot of the dolphins and a lot of larger whales just have one calf, and they raise it kind of like we raise our kids, because they require a bit more work and a bit more protection than sea star babies. Great question.
Okay, there are so many questions here in the chat. It's amazing. But Miss Mondor's class, someone has asked which, I'm going to say sea animal or ocean animal is the most dangerous.
Oh, so I would say one of the most dangerous ocean animals are actually jellyfish, things like box jellyfish, because they float around and they don't try to target you. They're not coming after you to sting you. But if you accidentally run into a box jellyfish, they can sting you so badly that you can have a lot of neurological issues and maybe paralysis and stuff. But there's a lot of, that's probably one of the scariest animals in the ocean, are actually jellyfish.
They look so cute.
And they look so harmless. They're just kind of like floating around and doing their thing, but they are a little bit scary sometimes. And my friends...
Mills, sorry.
Oh, sorry.
I just saw a brilliant question from Miss Mills' class that I think you're really going to like, Andrew, and I think will help a lot of kids understand sort of ocean animals better, is if fish, can they choke if they don't have lungs? So like, how does that whole breathing water, you were talking about the flaps earlier, how does that actually work?
Yeah. So for fish, they still need to get oxygen because oxygen is really important for all of the things that happen in our body. So what they do is they actually filter out the oxygen from the water with their gills. So they use their gills, kind of like how we use our lungs, but they use it to get oxygen out of the water instead of out of the air. And whether they can choke or not is a really good question. I think gills are a little bit better than our breathing system because there's 6 of them. So even if one gets clogged with something, which might cause a fish to choke, actually, wait, yes, I think fish, they can choke because if you do clog their gills or do something about that, then it might really impede their ability to breathe, but they have a different breathing system.
That's amazing. Okay, our friend Corbin has raised his hand about 400 times in the chat here. So Corbin, the floor is yours. Let's hear it.
How do eels sting?
How do eels sting?
Mhm.
Oh, so there is only
Yeah.
a couple types of eels that will give you a shock. So we're thinking about electric eels. And those are ones that usually live in the freshwater. And I think they're potentially classified more as fish. Anyway, what they do is they have an electric charge. So they use electricity, kind of like the electricity that keeps our heart beating and kind of like the electricity that keeps our brains going. They can use that to shock their prey. But other than that, a lot of eels don't sting necessarily, and they don't have venom. So that's a really good question.
How come their sting is poisonous? Is it, or like, because I think it's poisonous.
So for electric eels, their sting is not necessarily poisonous. It's just an electricity. So it's like getting shocked by an electrical outlet. So it's a different way because poison is usually something you ingest, whereas an electrical charge will interact with your body a bit differently.
I thought that it was poisonous, sorry.
Oh, no worries.
No, that's a great question. This is what we're here for, to ask these questions and to learn, because Andrew has some amazing answers. And so I'm so glad he's able to get to some of these today. Now, Miss Holden's class, Kaylee, is wondering, I think this is a great question. Is it possible to train sea animals? I know maybe with seals or walruses, but what about smaller animals like jellyfish or anemones? Can you do like positive reinforcement training with them? Like how might that look?
That's so I think for a lot of animals that are smaller like fish, you can do positive reinforcement. Jellyfish don't actually have a brain, and neither do anemones. They have a different type of nervous system where they don't need a central brain. So I don't really know if you could train a jellyfish. I think you can put food in a certain spot and it may remember that, but I doubt that jellyfish can do backflips. I think that you'd have to put a little bit of water circulation to make them do backflips. And anemones, they are not. I think you can desensitize them to things, like if you to touch, but usually they are not. You can't make them do tricks, sadly.
Amazing. Okay, so I know there's lots of questions, there's lots of hands raised. We want to get to some more, but first we're going to invite our friend Nyla, who's joining us from California. Now she, everyone, is part of our project. The Center for Global Education runs a project called Decarbonize, and we bring high school students from around the world together. So 45 countries around the world, we bring them together to meet and talk about climate change for about 8 months. So it's and there's art and there's all these wonderful things. And Nyla is one of our students in that project, and she lives just near San Francisco, California. But she was so inspired, I'm sure she'll tell you a bit too, but she was so inspired by some of the things she was learning that she started her own action projects in her school. And she talked to her teachers, she talked to her parents, and she started this amazing project that I'm going to let her talk about. But I asked her to come today to talk to all of you because I think it's amazing what you guys can do. You don't have to be an adult. You don't have to be Andrew, who's working at Oceanwise. You don't have to be me, who's working here. You today can do amazing things in your classroom, in your schools, with your parents that help the ocean, that help the earth. And so Nyla, I'd love to invite you to come to unmute and tell us about yourself and what you're doing.
Yeah, absolutely. So hi, my name is Nyla. And like Sarah said, I'm part of Decarbonize to Colonize, which is the kind of across the world youth conglomerate or group striving to fight and mitigate the climate crisis to like worldwide action. And Sarah also mentioned that I was so inspired that we as young people could make a difference, that I was able to start and create a webinar series where I basically give young people an opportunity to learn and give them access to be curious, ask questions to live expert panelists about the climate crisis and its underarching topics. So let me just preface everything with 3 words. I love oceans. Everybody who knows me know that during my weekend visits to my grandparents by the Jurassic coast of the UK, I would much rather be tide pool and fossil hunting than making sandcastles. I could ask every single question possible and be able to go exploring for the answers. Next slide, please. So imagine my excitement when I found out that while as a 4-year-old, I could not go to the Amazon, but my best friend gave me a book full of mind-blowing facts. Like, the mouth of the Amazon River is almost as wide as the distance from London to Paris. It empties 219 million litres into the ocean every single second. Do you know how crazy that is? That the Earth's bodies of waters are so interconnected that a giant rainforest in South America gives 1/5 of all of the world's river water flow. Facts like these can captivate people because we are so curious, we have to learn more. Next slide, please. This is how I've been able to get my webinars to work. For the past 6 months, each month I host a talk via Zoom where 1 to 3 experts join me and talk about the interconnectedness of everything. How Dr. Eston, a world-renowned entomologist, otherwise known as the marvelous bug lady, exhibited that saving our creepy crawlies is a fantastic step towards climate action. Why? Because so many of Earth's animals, whether it be marine life to creepy crawlies, are keystone species. They have the ability to change the whole environment of their habitat by changing one small habit, which is something that climate change is constantly forcing the animals to do. Everything is so linked that by caring for the bees in your garden, you can set off a chain reaction. So your siblings, the people who take care of you, your friends, even your neighbours will think, well, maybe if they care, I should too. But how do I know? I've seen it firsthand. You may not be able to read each individual note, but everything on this slide comes from people who've reflected the experience while watching my webinars. I was able to see a whole 2nd grade class come together creating art. I was able to see adults realizing that they have the ability to help us youth. Next slide, please. So 1 person, that seems so unbearably small, and sometimes it is. I can't lie, until I read the reflections and responses for just a 100 family in attendance webinar, I was sure that it was impossible for anybody to make a difference as 1 person. However, with role models, with people we can look up to, young people are just as powerful as any adult. If not, we're more driven because we're driven by hope. This is exactly what happened after Dr. Nathan Robinson and his team uploaded a video of them extracting a straw out of a turtle's nose. While talking with him, he showed us and everybody watching the webinar that the straw, telling us it became the most famous straw in the world, just due to the fact that people watched the video and they had to tell other people. It was interesting. They had to pass on the information. And they were able to expose such a sad thing, that a straw was stuck in the turtle's nose, through connecting with our emotions. Because as humans, we're able to connect through compassion, whether we use it for good or not. By exposing what was wrong, by showing everybody that that's not okay, and then it's sad that there is a turtle who's being harmed by the plastics that we're putting in the ocean, people are given a clear view of not only the sad, but the obvious solution, that that's wrong and we need to change it. Just by taking personal initiative that this group of scientists had to help our planet, 1 person made the whole plastic straw movement possible. So 40% of plastic that litters our oceans is left uncollected. 1 person can change that. Pre-COVID, I went to Hawaii and took it as an opportunity to extend my research, to observe how beaches in such a touristy people place would be so different to the likes of beaches in California. The beach was dotted with flying juice boxes, plastic bottles, plastic bags. And so I took it upon myself to clean a little bit of it up. With a few of my friends and support with some other holidays who noticed what we were doing, we cleaned up just a small section of the beach. It was small, but then we set off a chain reaction. Recently, when I was talking with an organisation called Take 3 for the Sea over email, I adopted their mantra. Taking 3 pieces of trash can be the difference between a clean habitat and endangerment. You can bring this to your community, don't do it alone. River, lake, and creek cleanups are all just as important. All bodies of water deserve your respect. Now, it's obvious not to use plastic straws, but did you think about how long you take in the shower? Or how these plastic, single-use and throwaway containers you take your lunch in can be harmful? Be creative with your solutions and alternatives. Conserving water and not wasting is key, but you can have fun with it. You can decorate your reusable boxes. Maybe set your 2 favorite songs on while you have a shower so you can be timely and have fun. Next slide, please. Oh, sorry. The big actions can also come from little steps. The 2 photos that I'm showing are photos from some work that I was doing as part of my, I think it was episode 2 or 3, and I talked with Dr. Nathan Robinson and Reserva, which is the Youth Land Trust. So big actions can come from little steps. People always say if you learn, you have to share it with other people. And that's how I work. I have to tell other people this really cool fact, just like I had to tell you all about the Amazon rainforest fact. And speaking up can mean making leaflets and giving them to all of the stores in your village, saying, please, can you cut down your plastic usage? Listen to others as well. Many restaurants in my little town now don't use plastic at all because some younger students passed out so many leaflets. Maybe a lemonade stand to raise money for organisations such as Reserva, a Youth Land Trust, and they're a group committed to getting the first fully funded youth reserve in the Chaco rainforest in Ecuador. You can see a photo of a little frog, and that's one of the species that they've been protecting. You can also see a drawing, and that was a 2nd grade student at my school who drew it for us. And it's just showing that you can create. But before creating your own group or initiative, and before coming together with your friends and saying, why don't we do something together, you should take a look and see if other people are doing the same as well. You can always find organisations and groups around your community, and you can support them and help be part of their group. Next slide, please. So you can create bee hotels, bug hotels, planting your own garden. But what we all can do involves encouraging others to do the same as us. Every action displaying your commitment will show someone else that they can follow your lead too. You can be the role models for your friends, for your classmates, for your school. I feel strongly that art is such a powerful way for young people to be taken seriously. Even author and artist Oliver Jeff has agreed while in conversation with myself and our very own Sarah, who's here today, as guest panelists. In drawing pictures, writing songs, making collages, you can declare that fighting the climate crisis is important to you in a way where all you need are your emotions. One of the best ways you can do this is actually part of the group I am part of. It'll help us here at Decarbonise to Colonise. If you create art, you can put it up across your community, but not only will it make an impact on those you display it at home, but if you send it to us, we can very, very proudly bring it with us when we advocate for youth voices in climate action while attending the United Nations COP at Glasgow later this year. Next slide, please. So I've told you what you can do once you've learned, and I've told you what I've been able to do, but how will this be interesting enough for you to learn about? I encourage you to keep participating in events like this one, where real people are saying real thoughts. There's something so special about hearing somebody speak from their heart and their experiences, and then of course, getting to ask as many questions as you like. You can register for my webinars or take a look at the recorded ones from my YouTube channel, Dolphins Always Know Best. You can find talks with myself and all of the amazing professionals about glaciers, bugs, books, teachers, bears, turtles, rainforest sports. Everything and anything you could be interested is fit into a 45-minute episode. And my upcoming episode 6 is in collaboration with Animals Asia. Panelist and expert is their founder, Jill Robinson, and it is the last of the series. But if you tune in, you can learn about moon bears, you can learn about the animals in Asia and conservation. But I promise that you can ask as many questions as you'd like, because questions are important. Asking questions means that you are a change maker. So whatever you do, keep asking questions, keep finding out the answers and seeking solutions, because maybe someday you'll tell somebody a thought-provoking, mind-blowing fact that inspires them to follow your lead. Thank you. Sarah, I think you're muted.
Sorry about that. That is so me. I wanted to say thank you because that was amazing. And what I think is so great is you don't have to wait. You don't have to be an adult. You are in school. You're doing it now. And some of the most, I know that one of my special friends, Maya, who goes to school here at Muriel Martin St. Albert, she drew pictures and put them all up around her house to remind people to use less water and to use the compost and to close the door and to turn off the lights. I think even something like that, where you're changing, maybe you're drawing pictures and putting them up around your school to remind other students that conservation, even here in Alberta, impacts the oceans, because our water travels. It's just here. It's here on Earth, right? It goes from our glaciers all the way through our rivers and our waterways to the ocean. And everything we do in our communities ultimately impacts the ocean health. And so by taking, I think your parents too would love if you said, I learned today that I have to take shorter showers. I mean, that's what the ocean conservationists said. But I love your idea of pick 2 of your most favorite songs and use that to time your shower, so you know that you're not using up too much fresh water, that you're helping to act, and we can all work together. We don't have to be adults. Every day, you in your classrooms and in your homes can take actions that help the ocean, that help our conservation, our ocean animals. So, oh my goodness, that was so inspiring, Nyla. Thank you. And you might not be able to host a web series like Nyla, but you can make a difference. And I think that's such a powerful message. So thank you, Nyla, for sharing. Andrew, do you have anything to add about youth action?
Yeah, I was gonna say, first of all, Nyla, that is amazing. I think it's really hard to, sometimes in the scale of the problems in the world, it's really hard to look at them and figure out what we can do and feel like we're doing something in the world. And I think for all of you that are listening still, we know there's a couple things in the world that are we really need to address. And I think that one thing that my biggest takeaway is, no matter how old you are and no matter what age you are, you can do something about that. And what we're going to see in the next coming years is a lot of people doing a lot of amazing things. We're already seeing that. And so I think that one way, that one thing that we can all do is figure out one action that we can do that helps the ocean a little bit. One thing we can do almost every day, whether that's take shorter showers, maybe that's to use a little bit less plastic, maybe that's to eat a little bit less fish. All of these different things are things that we can do in these little actions to help the oceans and help the world as well, because as youth, you can have a big impact on that.
Amazing. So World Oceans Day it's been around since 2008, so quite a while now, and it started because of a Canadian initiative. And then the UN was so impressed by this Canadian Ocean Initiative that it said, we're going to make World Oceans Day a whole thing for the United Nations, for all of the member states. And so as Canadians, we should feel extra special and extra proud about how the whole world now recognizes Oceans Day because of something that we did here in Canada. And I hope you take that to heart and think, what am I going to do today? Andrew said it, Nyla said it. Now you can do, what am I going to do today to help the ocean on World Oceans Day? Now we've run out of time, and I know there's a million questions still because oceans are so interesting and filled with so many great animals and creatures, and I wish we could get to them all, but we'll have to save them for our next great adventure meeting. So Andrew, Nyla, thank you for joining us. To all of our students and our classrooms who have joined not only this event, but all our events this year, thank you so much. I can't wait to see you again coming in September. We're on a bit of a break now over the summer. Everyone has to go out and find some way, do a cleanup in your community, do a cleanup on a beach, do a cleanup in your backyard. Anything that you decide to do to help the environment is going to be amazing for the conservation of our animals and our species and our world. So thank you for your dedication to learning about the earth and learning about animals. And I cannot wait to hear more about what you're doing when we come back together in September. So thank you, everyone. Have a wonderful day, whether that's your morning, your afternoon, your evening, wherever you're joining from. Thank you. It was great to see you. Have a wonderful day.
Bye.
We had a great time. Bye.
Mommy.
Question. Next time.